Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Tasya Putri Sari and I'm from Mathematics Education Class D. Now, I'm going to present about the basic of matrix. So the first is the definition of matrix. So what is matrix? Matrix is a rectangular arrangement that enclosed by a bracket. We can use regular bracket or square bracket like this. This one is an example of matrix. There are 3, minus 2, 0, 1, minus 27, 5, and all of them in a bracket. And every number in the matrix is called an element or an entries of matrix. And the horizontal listings of the elements are called rows, and the vertical listings are called columns. And for this matrix, there are two rows. This is the first row and this is the second row. And the element of the first row are 3, minus 2, 0. And the element of the second row are 1, minus 27, and 5. And there are three columns. This is the first column, the second column, and the third column. The element of the first column are 3, 1. The element of the second column are minus 2 and minus 27. And the elements of the third column are 0 and 5. And we can say this is the 2 by 3 matrix, or we can say that the order or the dimension of this matrix is 2 by 3 because there are 2 rows and 3 columns. And a matrix usually labeled with a capital letter, and the entries of that matrix are labeled with the same letter in lowercase with a double subscript. This is for the example. And the first subscript refers to the entries row, and the second subscript refers to its column. For example, is this one, A11. That refers the element of matrix A that is in the first row and the first column. And for example, another example is this A21 that reverses the element of matrix A that is in the second row and the first column, and so on. Next, there is types of matrix. There are 9 types of matrix. The first type is row matrix. Row matrix is a matrix with only one row. For example, is this matrix 3, minus 2, 0. There is just only one row. And the next type is column matrix. Column matrix is a matrix with only one column. For example, is this matrix 26, 89. There is just only one column. The next type is square matrix. Square matrix is a matrix that has as many rows as column. For example, is this matrix 0, 1, minus 1, 5, 3. Because the many of row and columns are same, that is 2. So this matrix is a square matrix. And then the next is diagonal matrix. Diagonal matrix is a matrix that all elements of that matrix are 0 except the main diagonal. For example, is this matrix. All elements of this matrix are 0 except the main diagonal. The main diagonal of this matrix are 3, 5, and 9. And the other example is this matrix. All elements of this matrix are 0 except the main diagonal. The main diagonal of this matrix are 1 and 3. Next, there are upper and lower triangular matrices. Upper and lower triangular matrices are a matrix that all elements in the upper or in the lower of the main diagonal are 0. For example, is this matrix. All elements in the lower of the main diagonal are 0. So we can say that this matrix is a lower triangular matrix. And the other example is this matrix. Because the all elements in the upper of main diagonal are 0, so we can say that this matrix is an upper triangular matrix. Next, there are zero matrix. Zero matrix is a matrix that all elements are zero. And then this is the example. Next type is identity matrix. Identity matrix is a matrix that all elements of the main diagonal of matrix are 1. This is for the example. Next is a transpose matrix. Transpose matrix is a matrix that has row that origin from the initial matrix column. For example, there is matrix A, 2, minus 1, 1, 3, minus 4, 5. To find the transpose of matrix A, we can interchange the first row to the first column of the transpose of matrix A, and the second row to the second column of the transpose of the matrix A. So this one is a transpose of matrix A. Next is a symmetry matrix. Symmetry matrix is a matrix that the transpose of the matrix is equal to its matrix. For example, there is matrix A, minus 1, 2, 2, 0, and this is the transpose of matrix A, minus 1, 2, 2, 0. We can see that the matrix of A is equal to the transpose of matrix A. So we can say that the A is a symmetry matrix. Next is matrix operation. There are 6 operations of the matrix. There are matrix addition, matrix subtraction, matrix multiplication, matrix determinant, and matrix inverse. The first is matrix addition. Two matrices can be added together if the dimension is the same. For the example is, there are matrix A and matrix B, and we can see that the dimension of matrix A same with the matrix B. That is 3 by 2 matrix. So we can edit each element of matrix A and B in the same position. That is 1 plus 3, 4 plus 6, 2 plus 4, 5 plus 7, 3 plus 5, 6 plus 8. So the matrix addition we can edit if they have the same dimension, and we can edit the element in the same position. Next is matrix subtraction. Two matrices can be subtracted together if the dimension is the same. So the subtraction of matrix similar with the addition matrix. For example, is matrix A and matrix B. The dimension is the same. There is 3 by 2 dimension, and we can subtract them with the element of in the same position. 1 minus 3, 4 minus 6, 2 minus 4, 5 minus 7, 3 minus 5, and 6 minus 8. Next is properties of matrix addition and subtraction. There are 3 properties. The first property is matrix A plus matrix B is equal to matrix B plus matrix A. The second property is matrix A plus matrix B in a bracket plus matrix C is equal to matrix A plus matrix B plus matrix C in bracket. And the third property is matrix A minus matrix B is not equal to matrix B minus matrix A. Next, there is matrix multiplication. Matrix multiplication, there are two types. The first type is matrix multiplication with integers. For example, there is matrix A and the integers r is equal to 2. And to multiply the matrix with the integers, we can multiply the integers to every element of the matrix. So we can multiply r with A is equal to 2 multiplied by 1, 2 multiplied by 2, 2 multiplied by 3, 2 multiplied by 4, 2 multiplied by 5, and 2 multiplied by 6. So next is multiplication of two matrices. Two matrices can be multiplied if the many of rows from the first matrix is equal to the many of columns from the second matrix. For example, there are matrix A and matrix B. Because the many of rows from matrix A equals to the many of columns from the matrix B, so we can multiply them. So to multiply matrix A and matrix B, we can multiply the first row from matrix A. We multiply by the first column from the matrix B, and we put in the first row and the first column. And then we can multiply the first row from matrix A multiplied by the second column from matrix B, and we put in the first row and the second column. And then we multiply the second rows from matrix A multiplied by the first column from matrix B, and we put in the second row and the first column. And then the second rows of matrix A we multiplied by the second columns from matrix B, and we put in the second row and the second columns. And then next is properties of matrix multiplication with integers or other matrix. There is 6 properties. The first property is K as an integers multiplied by matrix A plus matrix B in a bracket is equal to K multiplied by matrix A plus K multiplied by matrix B. The second property is K multiplied by matrix A minus matrix B in bracket is equal to K multiplied by matrix A minus K multiplied by matrix B. And the third property is K multiplied by matrix A multiplied by matrix B in bracket is equal to K multiplied by matrix A in bracket multiplied by matrix B. And the next property, matrix A multiplied by matrix B multiplied by matrix C is equal to matrix A multiplied by matrix B in a bracket multiplied by matrix C is equal to with matrix A multiplied by matrix B multiplied by matrix C in a bracket. And the next property is matrix A multiplied by matrix B plus matrix C in a bracket is equal to matrix A multiplied by matrix B plus matrix A multiplied by matrix C. And the last property is matrix A plus matrix B in a bracket multiplied by matrix C is equal to matrix A multiplied by matrix C plus matrix B multiplied by matrix C. Next, there is matrix determinant. The determinant of a matrix A is given in parenthesis notation, and we can write the determinant of matrix A as like this. And the determinant we can find in the square matrix. For the example, is the determinant of 2 by 2 ordered matrix. There is matrix A, and to find the determinant of matrix A, we can subtract it the product of the main diagonal and side diagonal. So the determinant of matrix A is A multiplied by D minus B multiplied by C. Next, there is determinant of 3 by 3 ordered matrix. For the example is matrix A, we can find the determinant of this matrix with the Sauer's method. The first step is we can remove the first column and the second column of the matrix to the side, and then we draw a diagonal line that connect each of the 3 elements like this, the 3 element, and then lines that fall to the left give the sign plus, like this, plus, 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 and then the diagonal line that fall to the right give a sign minus, like this, minus, 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 and then the next, the determinant is calculated by multiplying each element in a diagonal line and giving a sign according to the sign in the line, like this. So A multiplied by E multiplied by I plus B multiplied by F multiplied by G plus C multiplied by D multiplied by H minus C multiplied by E multiplied by G minus A multiplied by F multiplied by H and minus B multiplied by D multiplied by I. So that is to find the determinant of 3 by 3 ordered matrix. Next, there is matrix inverse. A matrix of A has an inverse if there is a matrix B that can form the equation matrix A multiplied by matrix B is equal to matrix B multiplied by matrix A is equal to I, or we can say that I is an identity matrix. And the inverse of orderly matrix 2 by 2 is like matrix A. This is matrix A can be formulated with the inverse of A is equal to A over the determinant of matrix A, and we can multiply all of them to the adjoint of matrix A. The adjoint of matrix A is we can interchange the element of main diagonal, and then we interchange the sign of the side diagonal. So the inverse of matrix A is 1 over A multiplied by D subtract A minus B multiplied by C, and we multiply them with the adjoint of matrix A, D minus B minus C A. Next, the example of matrix inverse. There is matrix A, and the inverse of matrix A is 1 over the matrix of the determinant of matrix A. There is 3 multiplied by 3 minus 1 multiplied by 1, and we multiply them with the adjoint of matrix A. That is 3, 1, minus 1, and 3. So this is the result. And next, the properties of the matrix inverse. There is 5 properties. The first property is matrix A multiplied by the inverse of matrix A is equal to the inverse of matrix A multiplied by matrix A is equal to identity matrix. And the second property is the inverse of matrix A, and we inverse that again, is equal to matrix A. And the third property is matrix A multiplied by the inverse of matrix B is equal to the inverse of matrix B multiplied by the inverse of matrix A. And the fourth property is if A multiplied by X as an integer is equal to matrix B, then the X is equal to the inverse of matrix A multiplied by matrix B. And the last property is if X multiplied by matrix A is equal to matrix B, then the X is equal to matrix B multiplied by the inverse of matrix A. And that's all from me. Thank you for watching. Bye.